In this lesson, we'll continue to talk about geometry, and specifically we'll be talking about how to measure area. And when you measure area, you use what are called square units. So our objectives are to, number one, use square units to measure area, and number two, use dimensional analysis to change units for area. So square measurements are used to determine the number of square units it would take to cover the surface of an object. So unlike perimeter, where we're going around the edges of an object, we're interested in how many square units it would take to cover the entire object. And in the English measurement system, some common measures for area are square inches, square feet, square yards, and square miles. And we use an exponent to write these. So for square inches, we write inches to the second power, feet to the second power, yards to the second power, and miles to the second power. But when we read these, we say square inches, square feet, square yards, square miles. So we say the square first. In the metric system, the base unit of square measure is the square meter. And related units of square measure are the square millimeter, the square centimeter, the square decimeter, the square decameter, square hectometer, and square kilometer, written very similarly with an exponent of 2. So as we mentioned, to measure area means to determine the number of square units it would take to cover an object. Now that object doesn't necessarily have to be rectangular. As you can see here, we still would be measuring the area by trying to determine how many squares are inside these shapes. Here it's a little clearer to see because we could just go through, we could actually find the area just by counting the number of squares that it takes to fill up this entire shape. But in either case, we're looking for the number of square units that it takes to cover the inside of an object. So for example, this triangle here, you've got 1, 2, 3. Looks like you probably have about 4, because these two would make 1 and then a half. So they may not be entire squares, but we do want to know how many of those square units it would take to cover that entire object. So let's take a couple of minutes to talk about a square inch. When you have a square, that's a four-sided object, all sides exactly the same measure, and if each side is 1 inch, even though it's not written on all of these, it would be 1 inch, then this would be 1 square inch. It's a square that's 1 inch on each side. Now this square inch could be one of many squares covering the surface of a larger shape. And you can see here we have a larger square that's actually 3 inches by 3 inches. So if we were to count these, 1, 2, 3, 4, 5, 6, 7, 8, 9, in a 3 by 3, it takes 9 square inches to cover the surface area. Because remember, we're trying to cover this entire area of the shape. Now a square inch can be related to centimeters as well. If you'll recall, it takes about 2.54 centimeters to make up an inch. And so here we have a square inch. Here we have a shape that is also a square inch, but it's marked off in centimeters. So a square inch is about 2.5 centimeters by 2.5 centimeters, or 2.54. So if I find the area by multiplying these two numbers together, like we did when we had the 3 by 3, it turns out that there are about 6.5 square centimeters in a square inch. It's not exact, so I'm going to use the symbol approximately equal to here, but it's approximately 6.5 square centimeters inside of a square inch, which brings us to this unit fraction, 1 square inch over 6.5 square centimeters. And of course, with all unit fractions, depending on the conversion you're trying to make, you can write this as the other unit fraction with the square centimeters on top and the square inch on bottom. So you can see that 1 square inch was 6.5 square centimeters, and similarly these other conversions have been made, and we know that 1 square foot is approximately 0.09 square meters, a square yard 0.8 square meters, a square mile 2.6 square meters, and finally, to measure land, we use an acre, and its metric equivalent is the hectare, and it's 0.4 hectares. And so I've taken each of these equivalent or approximate equivalent measurements and made unit fractions so that I can use each of these in dimensional analysis as needed to make the conversions. So we can use the appropriate unit fraction to make the conversion from 90 square centimeters to square inches. So if I want to convert 90 square centimeters, I can write that over 1. And the unit I'm trying to convert away from is square centimeters, so that unit's going to go on the bottom. Now if I'm lucky, I'm going to have inches or square inches related to square centimeters down here somewhere, and in fact I do. Here it is. So that's the exact unit fraction that I need. And remember that these units will be converted out now, and I'll be left with, and these ones we don't need, 90 on the top, 6.5 on the bottom, square inches, which is the unit I was trying to convert to. And then if I just take my calculator and do 90 divided by 6.5, I get about 13.85 square inches. And just pay attention to the number of decimal places that you need to round to in order to get the answer right in the online exercises. So if I want to convert 120 square yards to square meters, I'm looking for the relationship between square yards and square meters, and I see it right here and right here. So let's see which one we need to use. 120 square yards, put that over 1, times, trying to remove the square yard units and get square meter units. So I'm going to need this one. So the 0.8 square meters and 1 square yard on the bottom. So it's okay to use the approximately equal to. Just be sure, again, you pay attention to the rounding directions. Square yards are now going to be converted out, and I'll be left with 120 times 0.8 and square meters. So multiply that out to get 96 square meters. So we'll take a few minutes to talk about the concept of land measurement, and an acre is a common measurement we use for land. A square that is 208.71 feet by 208.71 feet covers approximately 1 acre. So the area inside this gold square would be approximately an acre. Now, it is not necessary that the acre be a square acre, such as the one you see here. It could be a rectangle or some other irregular shape, but just to help you understand the concept of how much an acre would cover, approximately 209 feet by 209 feet is going to give you an acre. It turns out that this is actually 43,560 square feet. So we're really, even though we don't use the square feet in our units, we're really covering our shape still in square units, but we're calling that an acre, and it consists of this many, 43,560 square feet. Now, in the metric system, a square that is 100 meters by 100 meters is what we call a hectare. And as you can see, once again, the metric system works with powers of 10, so it's a little bit easier to work with. The numbers are just nicer. And we can also say that a hectare covers 10,000 square meters, because if you were to multiply the 100 times the 100, that would give you 10,000. Meter is square meters. And the relationship between hectares and acres is that an acre is 0.4 hectares. So if I want to convert 4.7 acres to hectares, I will do this the same way that I would normally do my dimensional analysis. Put a 1 under there. I want to remove or convert out the acre unit, and I want a hectare unit. So I'm going to look for a hectare related to an acre, 0.4 and 1. The acre units are now converted out, and I've got 4.7 times 0.4. All of that is over 1, and it's all in hectares now. And so all I have to do is multiply those out, and I will get 1.88 hectares for 4.7 acres. And so we can use what we know about unit conversions to solve application problems. So here's our example. Japan has a population of 127 million people, and the area of the country's land is 144,689 square miles. So we've got 127 million people living in a land mass, we'll put a P for people, that is 144,689 square miles. And for miles, you need to remember to put MI so that it's not confused with meters. Now, what they're asking me to find is the density per square kilometer. So I want to convert this by removing the square mile unit and getting an answer that is in square kilometers. So I'm looking for how square miles and kilometers, square kilometers are related. So for every 1 square mile, there are 2.6 square kilometers. Now the miles units are going to be removed, and I'm going to end up with 127 million people over 144,689 times 2.6, and that's still in square kilometers. So we're looking for people, or population, per square kilometer. So we want people in the numerator and square kilometers in the denominator. So if I multiply this out, I'll get 127 million divided by 376,191.4, and that divided out, and that's people per square kilometer, gives me 337.6 people per square kilometer. And depending on the instructions, you may be asked to round this to the nearest whole number, and so you might say that there are 338 people living in every square kilometer of Japan.